Okay, welcome you all to the second video. Here we will be doing the seismic analysis of the structure which we had created in the first video. So we'll open the same file, that is the tall buildings tutorial. Now we had already analyzed the structure and therefore we can see that it is a locked model. So first we will have to unlock the model. By unlocking, only the analysis results will get deleted. Rest the properties, the load conditions will remain the same. Now click OK. Once the model gets unlocked, go to Define menu, go to Load Patterns. Next, give a proper name, that is seismic load. Type is seismic. Auto lateral load will be IS 1893-2016. Add new load. Now modify the lateral load. Select the XY direction. If the eccentricity is required, then go for the eccentricity. The minimum eccentricity I set as default is 0.05. You can set to any value you want. For our case, we'll just keep it to 0.05. Next is the seismic zone factor. So the tabs asks for the seismic zone factor, that is per code, that we have to decide. We have to check the values from the IS 1893 part 1 2016. Site type also as 1, 2 or 3. Importance factor as 1, 1.2 or 1.5. Then the response reduction factor. All these four values are taken from the IS code 1893 2016. So to begin with, the zone factor Z, as per the IS 1893 2016, zone factor Z from the annexure E for Mumbai region can be seen here. Mumbai falls in the third zone, so the Z value is 0.16. Now for site type, from figure 2a, that is spectra for equivalent static method, the type 1, 2, 3, for that for these conditions we get SA by G values for natural period T. Here type 1 is rock or hard soil, type 2 is medium soil, and type 3 is soft soil. So we can consider rock or hard soil, so type 1 will be selecting type 1. Now for the importance factor I, from table 8 we can see that for important buildings the importance factor is 1.5. Next, for the residential or commercial buildings it is 1.2, and for other buildings it's 1. Residential or commercial buildings with the occupancy more than 200 persons. So in our case, the total floor height is 25. Per floor area is about 30 into 30, that is 900 square meters. So even if we consider one person for every 5 square meters, which is quite a huge space, one person per 5 square meter, so we'll have to consider that is per floor 18 persons, not 18, sorry, 180 persons per floor. So 180 into 25, that accounts for 4,500 people residing in that building. Even if we consider less number of people staying, as suppose 3,000 people staying, then that is still more than 200 persons. So we'll have to go for 1.2 as the importance factor. Next is the response reduction factor, the R. So here we can see that for RC buildings with ordinary moment resisting frame OMRF, the value is 3. For special moment resisting it's 5, but in our case it's ordinary moment resisting, so the value of R will be 3. So now as we defined earlier, for Mumbai it is 0.16. Site type we are taking it as 1, that is rock or hard soil. Importance factor as 1.2 and response reduction factor as 3. Click on OK. Either you can keep the wind load here or you can delete it. We'll just keep it. Then during the analysis we can select or deselect the required or non-required load conditions. So click on OK to exit from this drop down box. Next go to define, go to load cases. Here you can see dead, live, wind and seismic loads. Click on OK. Go to define load combinations. Now there are about 14 load combinations which are being done, which are generated by default. If you're not certain, then you can do one thing: select all, delete all the combos, then again add default on design combos, again concrete frame design. OK, you'll get again 14 numbers, only the names are different, that is from 15 to 28. Click on OK. The load combinations are also created. Already the load was applied, the wind loads, the live loads and the dead loads were applied. For seismic there is no need to assign the loads separately. Now go to analyze. Here we can go for set load cases to run, because we want wind, as per the standards, wind and seismic, they don't act at the same time. Either wind acts or the seismic acts. It's very rare that both will act, so we'll just consider that wind is not acting. So we'll select run do not run case for the wind load. So here do not run, rest all are running. Either we can just select the seismic load is only acting, or we can select dead and live and seismic, all three are acting. So we can do two cases here. First case where dead, live and seismic all three are acting. So run now. Saving model, then the model will run the analysis. Once the analysis is done, the structure looks like this. Now go to design, concrete frame design, view or revise preferences. It should be IS 456-2000, rest all the same. Gamma for steel 1.15, gamma for concrete it's 1.5. Click on OK. Again go to design, concrete frame design, start design or check. Wait till the design or check happens. Now it will show some design loading combinations do not have results available. That is because we had unselected the wind load option. That's why it is asking. Design will ignore such loading combination. Check if required load cases have been run. So click on OK. That's OK. So once the design is done, it asks, it gives this drop down box, that is analysis and design section differ for 6 concrete frames. Do you want to reiterate analysis and design? That means probably the 6 concrete frames are failing. So click on yes. Again it will run the analysis and again it will design on its own. Because we had selected the auto select beams and auto select column option, it will do its work by its own. It will do the work by its own. Okay. So once the design is done, that is the design check is done, you can go for verify all members passed. If it shows that two concrete members have failed the design check, do you want to select them? Even after doing even after checking, even after going for the design check once again, even if it shows the same thing that some of the concrete members have failed, then you can unlock the model and define the section properties, give new section properties, and then again do the same work. So for now, not to extend the video, we are just clicking at no. So now this was about designing designing the model when three load conditions, that is the dead load, the live load, and the seismic load, all the three are acting together. Now we will be looking forward to analyze the structure only when the seismic load is acting. So once we unlock the model, the analysis results of the model gets deleted. So once again we are supposed to run the analysis. So click on analyze, set load cases to run. Now select dead case as do not run case and live load also as do not run case, then only the seismic load is acting. So now select run now. The model will get analyzed. Once the analysis is done, you can see the displacements due to seismic load here. If you place your cursor, then you on any one level, for example if you place here, then you can see that ux, that is the displacement in the x direction due to the seismic load, is 34.831 mm. In the y direction it's 0.084 mm, and in the z direction it's 0.817 mm. So at every point it will give you the values of the displacement depending on in which direction it has moved. So here we can just make out that the slabs, they have just moved in the x direction. This is step 1/6. Similarly there will be again 5 steps from which we can see that where and all how and all the model has displaced and how much the displacement is in terms of mm. So now again designing concrete frame design, view revised preference. If it's 456 2000, click on OK or cancel, then again design concrete frame, then start design check. So once the design check is done, go to concrete frame design, verify all members passed. All the concrete frames have passed the design check. Click on OK. Done. Now this was about the design. In the reports, as mentioned before in the first video, there is the project report which gives the total explanation in detail about the types of loads, functions, analysis results, assignments, properties, structure data, everything. And in summary report, there's just a summary of the total building. So this is the summary report. Here the structure data. The story definitions are given. Next, the load patterns, response spectrum analysis results, story drifts, story forces, and many other things are mentioned in the summary report. So that was it about the seismic loading condition. That's it. Thank you very much.